Professor Mr. K. Balraj is working as a polymer consultant and teaching fellow in the area of polymer science and engineering at CEG Anna University, Chennai. He has completed AMIE in electrical engineering at the Institution of Engineers India, Calcutta, and MTech Polymer Science and Engineering at CEG Anna University. He is also pursuing his doctoral research work in polymer technology. His area of specialization includes polymer rheology, polymer processing, characterization and testing of polymers, polymer blends and composites, and insulation technology. He has in-depth experience on plastic properties, testing methods, and the relevant standards. He has more than 15 years of teaching experience in polymer science and engineering, including instrumentation in polymer industries, engineering plastics, conducting polymers, and rubber technology at CEG Anna University. He has guided more than 30 MTech students in their research projects. He has presented more than 20 research papers in the national and international conferences in the area of polymer science. He has published 10 research papers in the peer-reviewed journals.
Welcome to UGC lecture series in polymer science. In polymer science, the course we have been discussing so far is about polymer rheology. In the earlier classes, we have discussed about the relevance of rheology, particularly in polymer processing, and then viscoelasticity, which is very well applies for polymeric melts, and then the ways and means by which viscoelasticity is observed in polymers and a method to measure all those. And in the last episode, we have discussed about the additives and the different types of additives, master batches, and in this last part, we will look into the different types of mixers, particularly the high speed mixer, two roll mill, and internal batch mixer. In internal batch mixer, we will see one specific example, which is a Banbury mixer. All these are very well used in polymer industry for effectively mixing the polymer with additives, and finally a single screw extruder. Now, the types of mixing process, it basically depends on two mixing functions, that is one is blending and another one is compounding. Most of the times people do use these two terms for to convey the same thing, but then compounding is the operation which follows after the blending is over. First we will see what is blending. Blending mixing is used when the fabrication process will be followed by compounding process, that is pigments must be mixed into granules or in the form of powder, followed by injection molding. For example, thermosetting powders, mostly thermosetting plastics are in the form of powders, because these are mostly processed by a compression molding machine. So, there it will be useful if the material is in the form of a powder rather than in the form of a pellet. So, for example, thermosetting powders and fillers are often blends which will disperse upon fusion of the resin during molding. Next, compounding. Compounding mixing is used when accurate distribution and dispersion of ingredients is required. That is, for example, if you a typical rubber compound will have a specific ratio with respect to the amount of resin, the amount of filler, amount of antioxidants, amount of lubricants, so amount of catalyst, amount of curing agent. So, likewise, so here accurate distribution and dispersion as well as the measured quantity of ingredient is required in compounding. For example, in rubber compounding, 4 to 5 additives have to act together for efficient cross linking of the rubber. Blending. In blending, it is simply stirring together or blending of a number of solids. For example, polypropylene powder along with pigment and antioxidant, one can prepare a suitable mixture by which one can prepare either a chair, a plastic chair, or likewise. The result is a mixture of powders. The individual powder will remain and can be separated in principle. Compounding involves intimate dispersion of the additives into the polymeric matrix, that is, it requires a physical change in the component, high shear force to bring about the change, the polymer to be in the melted or in the rubbery state during mixing. So, in the blending that is not the case. In compounding, the polymer should be necessarily in the form of a melt state or in the form of the rubbery state. We will see some of the processes for blending first. You have a number of methods nowadays available, starting from the simplest method to the sophisticated high speed machines are available for efficient blending. As we have seen earlier, a virgin polymer or a virgin plastic would not suit the modern day to day application. That is why we have to go for mixing those plastics with additives. So, that is where this blending operation is important. The simplest one is by means of a twin drum tumbler. It is called a twin drum tumbler, where it has a drive which is fitted with two drums. This drive can rotate. As a result, mixing operation takes place inside these drums. The simplest is to tumble together dry ingredients using a twin drum tumbler. So, this is the earliest method for blending. The next method is by means of a ribbon blender. Here also a tumbling action takes place. Here the chamber will be stationary and the ribbons are nothing but the blades that is kept inside the chamber, which can rotate constantly. It can also scoop the material while reducing the size of the material. So, this is a typical ribbon blender. This is the outside chamber, and this is where the blades are kept. There are different types of geometries are possible. So, this is a spiral type blade which can rotate at a given speed, and then it can do the mixing operation. So, this is a cross sectional view. This chamber is stationary and then the blade inside can rotate. Mostly ribbon blender is useful for convective mixing rather than conductive mixing. In most of the convective mixers, mixing rotor within a static housing moves a group of particles from one region to another. That is the mechanism by which the mixing takes place. It necessarily moves particles in the bulk from one region to another region as the rotor rotates. Ribbon mixtures are available both as batch mixture as well as continuous mixture. So, that is, you can add it batch wise, or there are provisions to supply the mixture continuously. In either case, one can get the desired blend. The rotational speed in ribbon blender is typically in the range of 10 to 60 rpm. Next, we will move on to high speed mixture. So, high speed mixture are the modern form, that is, these are more sophisticated in the sense more controls are available with respect to temperature and speed, and also the rate at which the blending takes place is very rapid. This is mainly used for PVC dry blends. It is also used for drying the polymer, and also it could be used for incorporating pigments, that is colorants, to give nice aesthetic appearance. Apart from that, antioxidants could also be added when the material is particularly meant for outdoor application. Now, compared to the ribbon blender, high speed mixer will usually run at a very high speed in terms of several thousand rpm, and it will form a circulating powders which becomes heated because of high speed, and because it is subjected to movement, the frictional heat will be developed. This will be in the range of 152 degrees Celsius, and then the mixing tank can be single wall or it can be jacketed for temperature control. So, this is a typical high speed mixture. You have all the controls here for mainly the temperature control, and this is the mixer, and then this is the inside view of this mixer, where you could see the blades which can rotate at a very high speed, and the mixing takes place inside this vessel. High speed mixers is made of impellers. Basically, there are impellers kept at the bottom of the chamber. The chamber is stationary. Now, the rotational speed of the impellers is about 1000 rpm, and then the motors are used for rotating the impellers. So, this is a typical cross sectional view of the mixing action which takes place in a high speed mixer. So, these are the impellers which can it rotates in the direction as shown, and this is how the charged materials, the flux of the charged materials are like this. So, that is it is like a turbulent flow like phenomena is established inside this vessel. So, because it moves in all directions, a very well mixing is possible, and most of the times heat sensitive polymers are used, because heat sensitive polymers, when you process in conventional machinery, that will stick to the mold. Therefore, in such cases the high speed mixers are used, and also the mixing operation will mostly be the preliminary operation before compounding. This is a typical pattern, the discharge port where you can collect the mixture, and these are the impeller blades, and then this is how the powders are circulated, and a motor to propel this impeller. Next we will move on to dough molding compound. It is like a dough like blend, that is the name comes because of the shape of the blade, which is in the form of Z. So, the blade will be in the form of Z, that is why it is called a dough molding compound. The mixture itself comprises of two stainless steel bowls, in each of which there will be a mixing blade. The blades rotate in opposite directions, and most of the times it will rotate at the same speed. This is the scheme how a compounding mixture is obtained using a dough molding method. The powders are charged first, and then it is blended for about a minute, and then it is followed by addition of the resin along with catalyst for accelerating the reaction, and then shrinkage control additive are added, and then mixing is continued usually for a time period of 15 to 30 minutes. Once the slurry is homogeneous, next in the last stage the reinforcing fibers are added gradually. That will ensure that there is a thorough compounding that is obtained. These are blended into the slurry until they are distributed throughout the mix. Typically for a time about 5 minutes, this final blending operation will take place. So, this is a typical recipe of a dough molding compound. This is parts per 100. For 100 parts of resin, the shrinkage control additive will be 40 to 65 parts, and fillers will be 150 to 250 parts. And mainly in the dough molding compound, lubricant is the compulsory additive added to facilitate good processing. It will be 3 to 5, and catalyst in the order of 1 to 2, and pigments that is colorants in the order of 5 to 10 parts. Most of the plastic jars are prepared by this method, that is the raw material for that is the dough molding compound. Next blending method is by means of ball mill. It comprises of a cylindrical vessel as shown here, in which you have large number of steel or ceramic balls. It is supported on two rollers. As the two rollers rotate, this cylindrical vessel can rotate, and inside which you have all the steel ceramic balls, and then when you charge the powder inside, because of the crushing action, the mixture gets mixed well. This operation, it rotates the balls, tumble inside together with the powder. As a result, agglomerates of powder are broken down by grinding action of the tumbling balls. So, necessarily it is nothing but a dispersing action. In the last class we have seen about dispersive mixing and distributive mixing. In dispersive mixing, the idea is to reduce the shape of the size and shape of the particles as small as possible. That is what will take place in a ball mill. Next we will move on to compounding. So, compounding is the operation which frequently follow the blending operation. Here it involves high shear rate, therefore, it is a high shear process, and as a result much more powerful machinery is required. Therefore, the capital cost involved with a compounding machine is high. But the oldest and simpler technique is two roll mill, which we have discussed in the last class. This is a typical two roll mill. These are the two rolls, stainless steel cylindrical rolls, in which the material is fed in, and then one can obtain in the form of a film or in the form of a sheet. But then the problem with mixing on two roll mill is time consuming. That is, for example, it will take 2 hours to make for a 200 kilogram mixture on a 84-inch wide mill. So, this 84-inch refers to the diameter of this roll. For a standard size is the 84-inch roll. So, it will take approximately 2 hours, and apart from that, it also depends on the skill of the mill operator. As and when the sheets comes out, this has to be again pumped inside this in between the two rolls. That is why Banbury mixer, which is the advanced version of the two roll mill, came into picture. The Banbury mixer is a brand of internal batch mixer. It is an example for an internal batch mixer, and it is named after the inventor Fernley H. Banbury. Banbury mixture consists of a cylindrical chamber or shell within which materials to be mixed or deformed by rotating blades or rotors. It contains rotors which can rotate inside this cylindrical chamber, and that is how the mixing takes place. So, typically there are two rotors available in a Banbury mixer, which mostly rotates in the counter direction. Each has 2 to 4 blades which we mix by smearing the material against the chamber wall. Uniformity of mix is achieved by swirling action of the rotors. Now, the rotors and chamber walls are cored, that is cores are available on the chamber walls to accommodate the cooling as well as the heating channels. Now, weighted ram, a ram on top of which measured value of weight is kept, that will keep the mix in place. So, that will ensure that the mix does not move. The Banbury mixture will develop a complex flow pattern inside the chamber. As a result, efficient mixing is possible. Elongational flow as material enters and a shearing flow as it leaves. So, the material will enter, which will be a typical example for elongational flow, and as it comes out, which will be in the form of a shearing flow. So, this is a typical Banbury mixer. This is the entire outer casing, and then these are the two rotors which houses 2 to 4 spiral blades, and these are the cores where this will provide channels for cooling, and then the hopper this is where the material is fed in, and this is the ram on top of which weight will be there, which will this ram can move up and down. This will ensure that the mix does not move as and when this rotor rotates. Then the Banbury mixer, the blade motion causes the mixture to be sheared between the rotor blade tips and chamber wall. That is, there will be a very tight clearance between the rotor blades and the chamber walls. So, inside which the mixture is actually sheared. A typical cycle time is around 2 to 4 minutes, and general size is 50 to 75 kg, and the product that is obtained is in the form of a lump. Mostly Banbury mixture is meant for rubber processing, therefore, for compounding of rubber, hence it will be in the form of a lump. Internal batch mixtures such as Banbury mixer are used for mixing or compounding rubber and plastics. Its invention resulted in major labor, because in the two roll mill we have seen it depends mainly on the skill of the labor, because every time the sheet comes out, it has to be again fed inside the two roll for complete and thorough mixing, and it takes place for 2 hours. So, therefore, it is more labor intensive, whereas Banbury mixer invention resulted in labor as well as capital savings in the tire industry. The tire industry is the major industry where Banbury mixers are used for compounding of rubber. It is also used for reinforcing fillers in resin system, not only for rubber processing. In order to reinforce fillers with the polymers, Banbury mixers are used. Now, if you compare the Banbury mixer with a typical two roll mill, where both are used for compounding, the rate of output for a batch of rubber compound, for example 200 kg, would take 2 hours in a two roll mill, whereas a typical Banbury mixer we can produce 350 kg in a time of 15 minutes or less. So, that is how Banbury mixer takes a edge, and nowadays industries do adopt Banbury mixer. Next, we will move on to extruder. Screw extruders are the process tool used in compounding, injection molding, and injection blow molding, extrusion molding, and then extrusion blow molding. Screw in short form, screw extrusion technology is used as the plastic mixing and a melting device. Not only for melting, extruder could also be used for mixing. That is why we study this extruder under mixing processes. Basically, there are two types of extruder: single screw extruder and twin screw extruder. As the name implies, a single screw extruder will have only one screw, whereas a twin screw extruder will have 2 screws. There are a number of ways by which a single screw extruder can be classified, but then the most common classification is based on the ratio of the length of the screw to the inside diameter of the screw, which is normally called as L by D ratio. The standard screw extruders have a screw of LD ratio of 30:1, that is length 30, means the diameter is 1. It consists of a long steel screw which can rotate inside a steel tube which is called as a barrel. The size of the extruders range from small laboratory models, even nowadays tabletop models are available for conducting laboratory experiments, where the diameter of such screws will be only of half an inch, compared to the extruders that are used in industries, where typically it starts from 8-inch diameter, the diameter of the screw. Now, the extruder outputs can range from a few pounds an hour up to 1000 pounds per hour. It all depends on the, later on we will see the how one can increase the output range of a extruder. This is a typical single screw extruder diagram. This is the drive unit. This is the main barrel inside which the screw can rotate, and the barrel is surrounded with heater. These are the heating elements for providing the necessary heat energy to melt the polymeric pellets. The polymers in the form of pellets are usually fed through this hopper, and finally this the end point of this single screw extruder is connected to the die, that is where the final product is extruded. In most of the times you have cutters attached as an add-on to this single screw extruder, which can cut the extrudate in the form of pellets. Now, this barrel, as we have seen, is wrapped with heating elements to maintain the barrel at the melt temperature of the plastic. Most of the times the heating elements are set to the melt temperature of the plastic. Now, the plastic is pumped from one end of the screw, that is from the hopper end, to the other end by rotating the screw. As the screw rotates, the plastic is sheared and then it is slowly transported from the feed end to the molding end. Now, the rate at which the plastic moves from one end of the extruder to the other is controlled by the speed of the screw. Looking into the single screw extruder, it has 3 different zones that are called as feed zone, transition zone and metering zone. The feed zone, the material is pumped in and then it gets packed, and then in the transition zone it is melted, that is where plastification takes place, and in the metering zone thorough mixing takes place. As a result, whatever the form at which the polymer and additives or fillers, whatever added separately, when it comes to the metering zone, it is mixed thoroughly well. So, that is why extruder is also used as a mixing device. So, these are the 3 different zones with respect to a single screw extruder. Now, each zone has specific functions. So, in the feed zone, the main function is to transport the material from the hopper end to the compression zone. The compression zone is nothing but the transition zone. In the compression zone, compacting the material takes place. That is, the materials will gets packed slowly. As it is packed to the maximum extent, then it is compacted, and as a result it will eliminate any air gap. Presence of vacuum inside a mix will result in a final product with not so good mechanical properties. That is why elimination of air gaps is very much essential. In some of the extruders, vents are provided. Such extruders are called vented extruders. Through the vent, all these air will leak out. In the compression zone, it transports the material from compression to metering zone, and softening also takes place in the compression zone. In the metering zone, which is the final zone, thorough melting of the mixture takes place, and then thorough mixing also takes place. The material would be at a high pressure, and as a result it pumps the melt out. Now, the output of the single screw extruder depends on the screw dimension, that is based on the L by D ratio, and then the dimension of the die, the die dimension through which the extrudate is extruded out, and of course, the speed of the screw. Now, these are the factors which will increase the output of the screw, that is one can increase the screw speed, and also one can increase the diameter of the screw, and then the helix angle, that is the helix angle is the angle in the angle of this extruder screw, and that will also determine the efficiency of the output of the extruder, and of course, an increase in die diameter. So, increasing the die diameter will have other set of problems as well with respect to the thickness of the extrudate. to summarize, in this last episode we have seen the type of mixers, because a polymer, a virgin polymer alone will not fit into the modern day-to-day requirement. Therefore, a polymer has to be mixed with different types of additives as per the requirements. That is why the mixing operation is vital. So, in the mixing, in the earlier days, the mixing is based on twin drum mixing or a ribbon blender, and then the high speed mixer is the modern mixer for blending. And then with respect to compounding, Banbury mixture is very much widely used in, particularly in the rubber industries. Banbury mixture is an example for an internal batch mixer, and then the extruder basically converts the raw materials in the form of pellets. So, extruder could also be used as a mixing device. So, that is why extruder is also important in the mixing operations, which is very much required in a polymer industry. After looking into this episode, these are all the questions the viewers could think on. State the different types of blenders, what is meant by DMC, state the advantages of Banbury mixer over two-roll mill, explain the functions of various zones in the single screw extruder, because the single screw extruder there are different zones, and then each zones the functions are very much divided. So, therefore, understanding the functions of these zones is very much vital. Thank you.